Yeah, thanks for watching.
Woo!
These are my little pet hamsters. They're so cute. Oh, look at his legs. So fast. Wow. That's the best. Loved having these hamsters. Yeah.
Whoa!
Thanks for watching. So we're helping you with problem 3 with our day 2, so part 2, modeling trig equations. Make sure the audio is working this time. Thanks, Mindy. Shout out to her. Make sure this is working. Awesome. Okay, so problem part A says, what is the amplitude and the period of the function? And so the period is just how many months going on. So it tells us that April is x equals 4, because it's the 4th month of the year. And so we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so that's how many months we have. And so the period will just be 12 months. And when you put it into the formula, so remember the formula for the period is actually 2 pi over b equals the period. And so in this case, to find our b value to plug into the function, our period in this case is 12 months. And then you're just going to switch a roozy. And so it's actually 2 pi over 12 is what you're going to do for your b value into the equation. Cool. And so that can reduce to pi over 6 as well. Now the amplitude has a special formula that you want to memorize. Memorize for the test. So it's the maximum minus the minimum divided by 2. So in this case, we got to find out which is our maximum. So the 7th of July, so that's going to have degrees of 22. So that's our maximum y value. That's important. Because if you think about it when you do your graph, so how do you know if you want to use the 7 or the 22 into the formula? And so how you think about that is we'll be doing our months down here, right, all the way up to 12. And then we'll be doing our temperature that goes up and down throughout the year. And so our temperature, so our temperature is going to be doing our minimum and maximum, right? So we're going to go as high as 22 and as low as negative 17. So that's going to be our maximum and our minimum when we do our graph and help us with our function, with our equation. So let's go ahead and do it. So we're going to do 22 minus a negative 17, tricky, divided by 2. And so 22 minus a minus is going to actually be a plus because negative times a negative is a positive. And so 22 plus 17 is going to be 39. And 39 divided by 2 is going to be 19.5. Awesome. So that's our amplitude. So we just found our amplitude. Amplitude is 19.5. And then 12 months is our period. And so now write the cosine equation. And so in order for us to do that, we do need the formula for the midline. Slightly different than the amplitude. Instead of maximum minus the minimum, it's, do you remember? Do you remember? It's max plus the minimum divided by 2. And so in this case, it's going to be 22 plus a negative 17 divided by 2. And so the difference of 22 minus 17 is 5. So 5 over 2, 5 halves, which is also 2.5, which makes sense if you think about it with our graph up here. The difference between 17 and negative 17 and positive 22, the midline, about 2.5 should be between those. Good. Awesome. Okay, so now we can go ahead and do our equation. So that's for part B. So y equals, or if you want to say f of x or h of x, if we're talking about, so probably temperature could even be t of x. Whoa, go new boat. Is that lowercase t? Maybe. Okay, so temperature is equal to the amplitude first, right? Remember that? It's the amplitude, which in this case was 19.5, and cosine of the period. However, you're going to have two sections of the period going on. So 2 pi divided by 12, 2 pi over 12, because the period is 12. And then you're going to have x minus something that we're going to talk about in a second, and that's the phase shift for this part 2 problem. And then plus our 2.5, which again is our midline. Cool. And then again, 12 is our period there. Okay, so this last part, whoa. So let's see if I can explain this hopefully well enough to you. And so basically, what goes here, this value, is it's going to be an x value. And it's the x value that's associated with the y value, temperature. Or it could be, so it's basically the highest temperature x value that's associated with it, or the highest height, so highest like temperature. What else could it be? So sunrise, so the latest sunrise kind of thing. It's basically the max, okay? So in this case, we're looking for the y value that's the highest. And so again, that was 22. And so now we're looking for the x value. And so that's actually 7. So that's 7 comma 22. So that's 7, right? Because the highest temperature is 22 degrees. And that month of 7, which is July, that goes with that 22 degrees, that's actually what goes up here. So x minus 7. And the reason why is we're like phase shifting to that spot to make sure our cosine maxes out there at 22 degrees. So you'll see that now while we make draw our graph here for part C. Cool. So then we'll go ahead and split that there. Here's our x-axis, y-axis, good. So our maximum temperature again is 22 degrees Celsius. Our lowest is cold, lobber. Negative 17 degrees, good. There's our x-axis. Our midline is still, so a little bit lower there. So our midline is 2.5, so maybe this isn't quite to scale. Let's move up our negative 17 a little bit there-ish. Cool. Okay, so then there's our graph. And so we're starting with our maximum, right, which is July at 22 degrees, way up here, right? Awesome. And then, there we go. And so we're doing that to make sure our January negative 17 temperature is way down here, right? Yeah, so we want to make sure that our graph matches up. So at January, at 1 there, we're going to be at negative 17 degrees. And then we're going to go ahead and it's going to get warmer as we get closer to summer. Warmer, yep, closer to get summer. And then back down again. Awesome. Cool. So there's our graph. I want to label it as months of the year. Don't forget to label on the test. Make sure you label. So months of the year, as well as temperature. Cool. And then we can even plug in our equation, make sure we did it right, make sure we graphed it right. So let's take a look here. So we're going to go to y equals, and we're going to clear our graph there. And then we'll go ahead and put in our 19.5, which is our amplitude. Cosine of 2 parentheses, remember. And then we're going to go ahead and do, so 2 pi, that's it, divided by our 12. Or you could do pi over 6. You're right, it reduces to that. And then do our phase shift, x minus 7, where 7 is the month with the highest temperature, 22 degrees. That'll phase shift it to the right location. Then close another parentheses there. Good. And then we'll go ahead and do our midline, which is plus 2.5. Cool. Make sure we're still recording okay. Sick. Okay, there we go. So now the graph, we're going to have to use our minimum and maximum to fix it, because mine's cutting it off there. So this is the tricky part. So go to your window. I usually do the y values first. So we're down at negative 17, so maybe make it negative 19 maybe, just a couple lower. All the way up to 22 degrees, so maybe make it 23 or 24 degrees. Then our x value is going to be going from, so 0, really 1, but 0 to 12 months. Let's do one more, so 13. And now we can see that graph nicely. So as you can see, we had to phase shift a little bit, right? We had to phase shift over to make sure that down here, can you see it down here? Ooh, nice. That was cool. So we had to phase shift to make sure our graph started at January 1st and not at 0. So because 0, it starts going back up with our temperature. So that's what the phase shift did. That's why we had to phase shift at July at 7. Right? Does that kind of make sense-ish? Why 7 is our key there, our highest temperature, to phase shift to the right location? Cool. Now I'm just curious, at 12 months, I'm guessing that it's right towards the end. But let's just go and double check. So second calc value, 12 months, and December. And so, oh, yeah, not quite reached the bottom. That's interesting because of the phase shift. So, yeah, we're going to have to push trace. And it's not until we get all the way back to 13 months. Because of the phase shift, we're actually going to 13 before we get down to negative 17 again. Interesting. And that's, again, because of the phase shift. So back to January again. Remember, before we get back down to the negative 17 degrees. Cool. So that's what the phase shift is all about. Hope you understand that, why we had to do that at negative 7, because we had to phase shift to the right a little bit. Just a month. Cool. Okay, here we go. So how does the recorded temperature for September compare with the value of your equation? And so now we can just use our graph to help us find that. Two ways. Let's show you how to do that. So September would be what? It would be the 9th month, because it goes August, September, so July 7, August 8, September 9. So we're just going to go to second calc now, second trace. Can you see that? And it's option number 1. That's value. So make sure, let's do that. That'll be cool. That's it. So make sure you do value, and that'll help you. And then you can go ahead and plug in x equals September, which is 9, because it's asking for September, and then compare it to our record. So we'll put 9 in there, boom. So 12.25. So with our equation, we've got 12.25 degrees. So 12.25 degrees Celsius in September. And then if we go ahead and, how does that compare, right? How does that compare with the recorded temperature? And so let's go look at that recorded temperature. So it's actually 15. So we're actually low. Wow, we're actually low compared to what it should be with our equation there. Awesome. Okay, so how does the recorded temperature for September compare? So, well, the recorded temperature is 15 degrees Celsius. So we are actually, let's see, we're actually lower. Or if you want to say higher in the recorded temperature. So we're actually different. So we're actually off with our function. So we're actually off by, and then what's that difference there? Let's take a look. So 15 minus 12.25. So we're off by 2.75. So we're actually off by 2.75 degrees. Cool. So that's how it compares, right? Our record is a bit higher than what is expected from our equation. Cool. So that was problem 3. So thanks for watching. This one's definitely going to be maybe more like the test this year, depending on which problem we choose. We might change it up next year, but definitely this year, 2020. So thanks for watching, and watch next the practice test videos. Thanks for watching. Peace out.